Okay, in lieu of following on in class, here is a video where we're going to go through and show how to use the dimensioning tool. Sorry, I'm trying to get something else on another screen real quick. So we're going to use the same tool. I'm in the sketch, okay? I've double clicked on it, right? So you double click, it makes the sketch active. This will be open, and I will be using the same tool over and over again. That is the dimensioning tool. Finding it on the toolbar, you can press D to highlight it. Highlighted, it is on. Unhighlighted, it is off. So you can click on it both to turn it on and off, or you can press D on your keyboard, or you can press Escape to turn it off. Escape won't turn it on, but D will turn on. D again will off, or Escape off, okay? All right, so we are simply learning how to use the dimension tool. So there was a dimension here already, but just seeing the mechanics of how that was created, you would turn on the dimension tool, you would select the line. It doesn't look like anything happens until you start to move the mouse slightly, or your finger on the trackpad, and then it's kind of attached to your cursor. So to drop it and put it on the screen, you're gonna click again, and then it prompts you to type the dimension that you would like to make it. So if you just want to accept what's there, you can press enter. If you want to edit it, you can type a new number, and if you accidentally meant to change it and didn't, you can just double click on it and come right back in and change that size, okay? So that's just a simple dimensioning the length of a segment. We're going to be showing different ways to use this tool, okay? Now, I intended to really make this a rectangle, and so I'm going to turn on the perpendicular tool. You can search for perpendicular if you don't know, and I'm going to make one of these corners perpendicular. That will make it a rectangle because it was already a parallelogram, and I'll even make, maybe it'll be nicer to your eyes if we make one of these sides horizontal, kind of squared up, okay? Also, if you didn't turn your view cube to look straight at the work plane or the sketch that we're working on, it is parallel to the front plane, so you can click on the word front, or you can press on your keyboard the letter N. N will turn normal. If you press again, it'll flip to the back side, but pressing N will rotate it, okay? So I have a rectangle, and what I want to do is I'm going to dimension both kind of two dimensions of it, but I'm going to use two different techniques. Okay, so the first technique was, you know, like we had over there. So let's see, I don't think I have that written down, but let's say, let's make, here, dimension tool. Dimension tool's turned on. Let's make the solid line, let's just make this up. How about we make it 2.8 inches, okay? So that is now the distance or the length of that solid line, right? Just like what we did before. Another way to dimension a line, let's say the dash line this time, we could do the exact same thing, but another way would be kind of an indirect method here. That line runs in between the two solid lines. I can actually dimension the distance in between parallel lines, and that would effectively get the dimension of that. So instead of choosing that line, I'm going to choose this solid line. I'm going to start moving my mouse. I'm going to ignore the dimension line that's created, okay, because that's not what I'm trying to do. So ignore what Onshape's showing until you make your second selection. After choosing a second line, if they are parallel, you will get a dimension that shows the distance between them. And I'm going to make that 3.2 inches just as a demo. So now I have a rectangle that's 3.2 by 2.8. All right, that's it. Moving over to the right, there are a couple points. This easily could have been a line segment with endpoints. I chose to give you only points because I thought if I have a line here, people are going to click the line, and I don't want you to click the line. So the purpose of this is to show what happens if you click the endpoints of a line. Okay, this is the same thing as if you had endpoints. So if you click the endpoints, yes, you can get the distance in between those points or the length of that line. However, don't click yet. Keep moving your mouse. If you move your mouse around enough, you see that the dimension line rotates into different options. So when your cursor is in between the lines, you get the option to give the shortest distance. Okay, the shortest distance between 2 points is that straight line. However, if you can imagine kind of an imaginary rectangle that's not drawn on the screen, but kind of an imaginary rectangle where these two are like diagonal corners, all right? So as long as I'm kind of inside that imaginary rectangle here, I get that. But if I leave that rectangle, so I bring my cursor more to the left, okay, I get a vertical distance. All right, and if I come back inside here and I go vertically, so kind of leave the imaginary box and go up, I get a horizontal distance. So I wanted you to see that. Based on where you put the cursor, you can get a horizontal or a vertical distance, not just the straight distance. So for this little area, we were going to set the horizontal distance to 3, and then I'm going to use it again, the dimension tool again, between these 2 points, this time setting the vertical distance to be 4. Okay, all right. I'm going to move on to the next one and show that you could have just gone straight, used the shortest distance, and I'm making these points 6 units apart. Okay, so just again showcasing different ways to use the dimension tool, right? So shortest distance versus a horizontal and possibly a vertical. Okay, all right, moving kind of down to the next row of geometry. What I have here is an arc. There's always going to be a point kind of floating out there in space that represents where the center of that arc is. This line segment is not generally created when you make an arc. I just went ahead and did it to kind of make your eye see where the center was. You didn't need that line, but I wanted you to see that that's not some random point. That is actually the center, okay, of this arc. An arc is simply a fraction of a circle. Instead of having a full circle, you simply have a portion, a fraction of the whole circle. It is curving at a consistent rate of change, though, like a circle would be. It's just not gone all the way around. All right, to dimension an arc, the most common thing to do is to provide the radius, the distance from any of these points on the arc to the center, which basically decides how tight of a curve it is. A smaller radius is a tighter curve. A bigger radius will give you a more flat curve. All right, so dimensioning the arc is the common thing is giving a radius. So all you have to do is click on the arc itself and then move your mouse. It doesn't matter if you go inside or outside, and it will automatically give a dimension that's going to constrain the curvature of that by using a radius, which is the distance between any of these points to the center. I was going to make the arc here 4 inches. So it's still a very unconstrained sketch, like the endpoints aren't stuck in space, the center's not stuck in space, so you can still kind of move things around. What is constrained is simply that no matter what I move, how I move these points, the distance between the center and any of these has to be 4 now, okay? So when you have an arc, it'll automatically do the radius, right? If you have a full circle, though, it does something different. It will give the diameter, which is the distance all the way across the circle. Doesn't matter if your mouse is inside or outside the circle, it's still going to do the diameter, which is all the way across. I was going to make the diameter here 2.5 inches. Notice the symbol in front of the 2.5 is like a circle with a line through it, that it means diameter in an engineering drawing, where with the arc it put an R. R for radius, and I wish I could zoom in on that, but that circle with the line through it means diameter. Okay? All right, moving to the next one, we have just another arc. Again, I just did that for context to make sure that you could see where the center point was. Sometimes people think it's just some random point over in space, but you don't even need it, so I can delete that. That's not really, okay, just so you know, that's not some random point over there. All right, so using the dimension tool again, what I was going to do is show that you can dimension the length of the arc. Okay, so think of a circumference being the distance all the way around the circle on the circle. This is the distance along the arc, but from point to point. So to do that, you don't click the arc itself, you have to click the endpoints. Okay, so I'm going to choose the two endpoints. Now, it looks like it's wanting to give a straight line distance. I have to move my mouse kind of right on top of the arc, so I'm not clicking anything, I'm just moving. And once I'm on the arc, it changes to showing a new number with that arc symbol, and that is the length along the curve. So if I click right here, that's kind of like saying, yes, I want that type of dimension. You're selecting the type of dimension, then you can still move your mouse further out for just readability of where you're placing it on the screen. Click one more time, and then you can edit it. And so I am setting the arc length to be 5 inches. Now that didn't set the radius, right? I've only constrained length, so the radius could actually still be changed if I move the center closer, but no matter what the radius is, that arc has to be 5 inches long, okay? All right, moving down to here, we have 2 lines that are not parallel. Earlier, we had selected 2 lines that were parallel, and we got the distance between them. This time, we're going to select both of them, so ignore the dimension, just go select the second one. And this shows that if you select two lines that are not parallel, it will give you an angle measure. And I was going to set the angle between these two lines to be 37 degrees. So how we dimension angle measures is we simply select two non-parallel lines. All right. Next over here, I said set the angle between the solid lines to be 10 degrees. Okay, so I'm going to use the dimension tool. I've been tasked with making the angle between these two solid lines, which are not parallel. Even though they're not touching, right, they're not coming together to make a point, I could still adjust the angle between them. And so I was going to make it 10 degrees. That's closer to being parallel than they were, but not parallel yet. Okay, and then the symbol that you get, I mean, that almost looks like a distance between, but you have to look and see that little superscript O or 0, and that means it's degrees. All right. All right, on the next one, actually, I might hit pause right there, and we'll say that's like part 1 of this activity, and then we'll save these last 4 are slightly more advanced for like part 2.